Hello grade 12s and welcome to question number 9 of the November 2021 Physical Science Paper 1 exam. This question deals with electrodynamics, so that is generators and motors, as well as the section on alternating current or AC current. On your formula sheet, you're given a whole lot of formulae that you can use to navigate your way through the section on AC current. Firstly, we have the formula that relates the RMS current to the maximum current. There's the formula that relates the maximum potential difference to the RMS potential difference. Then we have three formulae that we can use to calculate the average power. Firstly, we have that the average power is equal to the RMS potential difference multiplied by the RMS current. Then the average power is equal to the RMS current squared multiplied by the resistance. And lastly, we have the average power is equal to the RMS potential difference squared divided by the resistance. These are the different formulae that you can use in this section, and grade 12s, it is incredibly important, I can't emphasize this enough, that you use the subscripts that are given. These subscripts are incredibly important in this section, and if you don't use them, you are at risk of losing some marks. So please write down the formulae correctly as they appear on your formula sheet. Question number 9 says a simplified diagram of an AC generator. So they're telling us that this is an AC generator connected to a 25 ohm resistor is shown below. The coils rotate anti-clockwise. So this is an AC generator, but we should be able to tell this without even looking or without the words AC generator being mentioned to us. We see over here the armature or the rectangular coil that is going to pass through the magnetic field. We have the two magnets with the north pole on this side and the south pole on the right hand side. Then we have the carbon brushes with slip rings that are connected to the armature. There is the external circuit, and in this external circuit we have a resistor that has a resistance of 25 ohms. There is an axle. So an axle is just a device that we can use to turn the armature, to turn the coil, and they have indicated on the sketch that it will be turning in this direction. That means anti-clockwise. So a generator is a device that is going to turn, right? And therefore we're going to have the energy conversion of mechanical energy to electrical energy. We turn the coil and therefore current is being produced. Let's now look at the questions. Question number 9.1 says, name the component that distinguishes this generator from a DC generator. In this case, since we have already analyzed the diagram that has been given to us, we know that the correct answer to this question is the slip rings. So write down the words slip rings. Or you can write down slip ring commutator, and that is going to get you 1 mark. Question 9.2 now says, in which direction will the induced current flow in section XY of the coil? Choose from X to Y or Y to X. I like to remember that in the alphabet, the letter L comes before M. So when we're dealing with motors, we make use of the left-hand rule. That means that the right-hand rule is reserved for generators. So when we use the right-hand rule, our index finger, that is the one that we point with, is going to point from north to south, right, in the direction of the magnetic field. Then we have that our thumbs are going to point in the direction of the thrust or the force being applied. So we know that this part of the coil is going to be moving downwards and our thumbs will point down. As a result, we're going to find that our middle fingers point in the direction from Y to X. This is according to the right-hand rule. And we can therefore say that in this section of the coil, the induced current flows from Y to X. So the answer to question number 9.2 is from Y to X, and that is going to get us 2 marks. We now move on to question number 9.3, which starts off with a sketch or a diagram, or rather we can call it a graph. They say the graph below shows the output voltage of the generator for 1 cycle of rotation of the coil. Remember, this is an AC generator. So when we look at this graph, we know that when it comes to AC current or AC potential difference, we don't deal with average values, but instead we're going to be looking at values like VRMS, current, so IRMS, etc., because this is for an AC generator. We look at the diagram and we see that the maximum potential difference is going to be 100 volts. That is Vmax. On the other side, here at the bottom, we also have 100 volts, and that does not mean it is negative, but rather in the opposite direction. So now question 9.3 says, define RMS potential difference. For 2 marks, we write down the definition as it appears in the exam guidelines, and we say the AC potential difference, which dissipates the same amount of energy as an equivalent DC potential difference. So this is going to get you 2 marks, and I do suggest that you learn especially this definition off by heart, because it is very easy to make mistakes, but also you're going to realize that most of the definition is underlined. So that means if any of those words or statements are left out, then you're not going to get your marks. We can now move on to question number 9.4, which says calculate the RMS current in the circuit. Whenever you are asked to calculate a new value, go and write down its symbols so that you know exactly what it is that you are required to calculate. It is IRMS. Now we ask ourselves, what information do we have available at this point? Well, we know Vmax. So remember, right at the start, we analyzed this graph and we remembered that at this turning point, we have Vmax. So Vmax is equal to 100 volts. So since we have the potential difference, we're going to have to make use of at least 2 calculations in order to determine IRMS. And grade 12s, there are 3 different methods that you can use to answer this question. Please consult the marking guidelines if you would like to see other ways. So we can say VRMS is going to equal to Vmax divided by the square root of 2. This is a formula as it appears on your formula sheet. We're going to start off by calculating VRMS, because if we have VRMS, then we can use the formula IRMS is equal to VRMS over R, which is the resistance, and then we will be able to determine, well, IRMS. Now you may be a bit confused at this point because where are we going to get the resistance? Well, if we go all the way back up to the top, you'll remember that this graph over here that has been given to us, this graph is actually for this device, this AC generator. And to this AC generator, we have connected a 25 ohm resistor. So that is the resistance. Let us start off by listing what we have. We know Vmax is equal to 100 volts, and we know that the resistance is equal to 25 ohms. So now we substitute. Vmax is 100. We divide this by the square root of 2, and we find that VRMS is equal to 70.71 volts. Now that we have the RMS, we can plug it into this formula with the resistance. So we say 70.71 volts divided by the resistance, which is 25. And when we plug this into our calculators, we end up with an answer of 2.83 amperes. So the RMS current in the circuit is 2,83 amperes. Grade 12s, again, when you write down these formulae, please do not forget all of the subscripts. The subscripts are important, and if you don't write them down, you may lose your marks. So you're going to get marks for this question as follows. Number 1, you're going to get 1 mark for your substitution into this formula. 1 mark for this formula, 1 mark for substitution, and 1 mark for your final answer. Please remember there are other methods that you can use, and you can find these methods on or in the marking guidelines. Question 9.5 now says, calculate the average power, that is P average, dissipated in the 25 ohm resistor. So this is the resistance still. I'm going to start off by listing everything that we have at this point. As you can see on the right hand side, we have a lot of information, and therefore there are many different methods that you could use to answer this question, because there are so many different formulae that we can use to calculate the average power. You can find the other methods in your your marking guidelines, but I'm going to use one method for now. I'm going to say that the average power is equal to Vrms squared divided by the resistance. When we plug the values into this formula, we remember Vrms we calculated in the previous question as 70,71. We know that the resistance is 25. And when we plug these values, grade 12s, we forgot to square this. This is a mistake that many learners make, especially when you're in a rush, right? So when we plug this into our calculators, we find that the average power is 200 watts. Remember, power is measured in watts, and if you leave out your SI unit, you're not going to get your marks. This question is out of 3 marks, so you're going to get 1 mark for the formula, 1 mark for substitution, and lastly 1 mark for your final answer. Question number 9.6 is the last problem in this video, and it says the speed of rotation of the coil is now doubled. That means we are turning the coil faster, 2 times as fast. Copy the set of axes below in your answer book and sketch the graph of output voltage versus time for the 0,1 seconds. Initially, we completed 1 cycle of rotation in 0,1 seconds. Now we are rotating the coil faster, and what that basically means is that we're going to complete 1 cycle in 0,5 seconds. We are going to be completing 1 cycle in half the time. So that's the first thing we need to take note of. 1 cycle will be completed in 0,05 seconds. Now I'd like to remind you of Faraday's law that was taught to you in grade 11. Faraday's law related the change in magnetic flux per unit time to the EMF, the output voltage. So if we look at this formula, which by the way is not supplied to you or given on the formula sheet, we see that time is at the bottom in the denominator. What we are doing is that we're decreasing the time it takes to complete 1 full cycle or 1 full rotation. So the time goes from 0,1 seconds to 0,05 seconds. That means the time is becoming smaller. If the time is becoming smaller, if we're halving the time, what is going to happen is that the EMF is going to become bigger. We're going to end up doubling the EMF. As a result of the time decreasing, halving, the EMF is going to double. Therefore, we know that the maximum value on the graph, instead of being 100 as it previously was, is now going to become twice as big, and it's going to be 200. So the graph that we should obtain is one that looks as follows. We're going to go up to a max of 200, right? Go down to 200 and complete one cycle in 0.05 seconds. We're not done yet. We need to show everything that's going to happen in 0.1 seconds. So now we go on up to 200, down to 200, and we finish off at 0.1 seconds. Of course, your graph will look a little bit better than mine when you draw it in your exam. You're going to get your marks, number 1, for having 2 full waves. Then you're going to get a mark for the period of the wave being 0.05. And lastly, you're going to get a mark for the amplitude of the wave being 200. That is going to get you your 3 marks for question 9.6. This brings us to the end of this video and question number 9, which was out of 15 marks in total. In the next video, we're going to look at question number 10, which deals with the photoelectric effect.